All right, so it's day 15. I checked that my microphone is working today. It's totally working today. I didn't screw that one up. So uh, let's go. Hopefully it's not too bad, but you never know. If you want to exit the cave, the walls are getting closer together. Your submarine can still barely fit, though the main problem is that the walls of the cave are covered in chitons and it goes down to bump anything. The cavern is large but has a very low ceiling, restricting your motion to 2 dimensions. Shape of the cavern resembles a square. Quick scan of chiton density produces a map of risk level throughout the cave. Your puzzle input, for example, this. You start in the top left position, your destination is the bottom right position, and you cannot move diagonally. The number at each position is its risk level. Determine the total risk of entire path, add up the risk levels of each position you enter. That is, don't count the risk level of your starting position unless you enter it. Leaving it adds no, don't count the risk level of your starting position unless you enter it. Leaving it as a risk your total. It goes on to path total risk. Path, the total risk of the path, the starting position of enters the risk is not counted. So the lowest total risk of any path from the top left to the bottom right. Okay, so this is a standard dynamic any path from the top left to the bottom right. Okay, so it's not a dynamic programming program. Dynamic programming would be if you, well, it could be a dynamic programming problem, I guess. Yeah, in fact, it is a dynamic programming problem. So let's treat it as one. I forgot to do this, so that's extra time. Day 15.py. So let's say raw equals this, and let's say grid equals, come on, copilot, you can do it, you can do it, you can do it. Parse input into a list of ints. Okay, now let's see if we can do it. There you go. Thank you. Okay. So, actually, I'll just write a function to do it because I think that will make my life easier. And I can just return line in. Perfect. And now I need from typing import list. And let me again do a type alias grid equals this, and then I'll do, let's just make my typing easier. And now def lowest cost path grid, which is a grid. Okay, this is going to be and uses dynamic okay, well, programming to find the lowest cost path from the top left corner to the bottom right corner. Cost of top left corner does not count. Okay, and so let's see. So no, so that doesn't work. So we'll just have to do by hand. Handle the last row, and let me just actually let me do nr equals len grid and see if this will be easier. Although actually it's I don't think I want to use dynamic programming. I want to use breadth first search. Okay, and so actually from heap queue imports heap push heap pop because I want to use a priority queue, right? So I think I don't need my double-ended queue. Okay, and queue equals this. Actually, that's right. This is a queue of cost row column. Okay, and let's think about how I want to do this. Well, we'll just do it the naive way and see if it works. While queue cost RC equals heap pop Q, if R equals NR minus 1 and C equals NC minus 1 return cost, so let's see if it did it right. Cost row columns equals heap pop of Q. If I'm in the bottom right corner, return the cost. That's true. And give me a commented out print function. That's funny. And then for DRDC, and so I look at what was diagonals allowed. You cannot move diagonally. Okay. So new row, new column. If new row is less than 0 or new row is bigger than or equal to, see that's a problem. So I'm going to call it R underscore and C underscore. See, it's using NR for both new row and also number of rows. And so if that or, and let me rewrite this, if yes, so I'll rewrite it this way. So if this is on the thing, I heap push that, and otherwise raise exception no path found. Okay, and so let us assert that actually let's say grid equals parse raw and assert that lowest cost path grid is 40. So let's try it. My guess is there's probably some inefficiencies in there that are gonna hurt me. Right, this should be R underscore C underscore R underscore C underscore and let me do visited. I'm just gonna do this, right? Visited equals 0. Like anytime I visit someplace for the first time, that's got to be the lowest cost way of getting there because of the priority queue. So I'm just going to do an optimization and RC not in visited visited dot add. Yeah, so let me just do that. That'll just, it's efficiency optimization. Okay, so let's just print it and see what it is, and see what I got wrong. That's a lot. All right, so let us add this back and see what happens. Okay, well that's a okay. Did I parse it wrong? I think I parsed it wrong. that's part of the problem. All right, return int x for x in line. I don't need line.split, I just need line. Okay, let's try this again. Okay, so that worked. And so I should not have let copilot write the parsing code because it did me wrong. Okay, good. So let's go get our puzzle input, see how big it is. It's big, that's fine. Should be okay. Day15.text, put that there. And now if name equals main, and again it always does the wrong thing, raw equals open data day15.text.read, that's right. Grid equals parse raw, print lowest cost path grid. Okay, so let's try it. 435. So let's see if that works. That's the right answer. Okay. Now you know the finding you can try. The entire cast is actually 5 times larger in both directions than you thought. The area you originally scanned is just one tile in a 5x5 tile that forms a full map. The original map tile repeats to the right and downward. Each time the tile repeats to the right or downward, all of its risk levels are one higher than the tile immediately up or left of it. However, risk levels above 9 wrap around to 1. So if your original map had some position with a risk level of 8, then that same position on each of the 25 total tiles would be as follows. Because the full map is actually 5 times larger, that position occurs 25 times once in each duplicated tile with position shown above. Here is the full 5 times as large map. Right, and each time the tile repeats, the right or downward, all which risk levels are one higher than the tile immediately up or left of it. However, risk levels above. Okay, so so let's say grow grid returns a grid, and then that's good. New grid equals 0 for blank in range, nc times 5 for underscore in range, and r times 5. So that will make it 5 times as big, right? And now for let's say for I in range 5, for j in range 5, for r in range r, okay, so equals grid equals grid rc plus I plus j, okay? So, and equals shrink grid r plus, and so let's just write the shrink function. Int if x is bigger than 9, let's say while x is bigger than 9, x minus equals 9, right? So risk levels above 9 wrap back around to 1. So 9, it'll go to 10 and then subtract that. So I think that's right. Okay. And let us say 5 times as large. So let's grab this. raw huge is this. And so what I want to do is I want to assert that grow grid equals parse raw huge. So let's just do that and make sure that I've grown it correctly. List index out of range. Okay, so let's go check this. R plus 5 times I, C plus 5 times J is what I want, not the other way around. Let's try it again. Error list index out of range. Print ij rc r plus 5 times I, j plus 5 times c. I hate that it does that. So let's see what I did wrong there. 45. So that's 1, 0, so that should be fine. Grid RC. Let me split this up into two pieces. New value equals, because I don't know which line it's giving me the error on. Okay, so let's try it again and see where I get the error. Okay, new grid. Oh, whoops. So, well, I screwed up this. That could be the problem. Okay. Okay, so that works, but okay, well that has a lot of zeros in it, which is definitely not right. So say print ijrc new value. Okay, so let's do that again. So those new values are never never 0. So why am I getting zeros in there? Because this should be not 5. This should be r plus I times nr, and this should be j times nc. Okay, so I screwed that one up pretty good. Okay, good. And now assert that grow grid equals parse raw huge. Okay, so let's see if that works out right. Okay, that works out right. So now my growing function is correct. And I'm still printing something that I don't want to be printing. Assert that lowest cost path of grow grid equals 3:15. And we'll see if this takes too long to run. It might take a long time to run, but nope, it didn't. Okay, why am I still printing stuff? Because I still have this. Okay, and now print lowest cost path grow grid. Okay, so let's run this. 2842. That is the right answer. Okay, so yeah, well, I mean, what's going on here? The only thing that's going on really is that I used heap push and heap pop to do priority queue. There's also like a priority queue library, but I always do my priority queues by hand, like heap push and heap pop. And so the idea of a heap is a data structure that basically reasonably quickly allows you to insert new elements and reasonably quickly allows you to extract the smallest element, right? And so when I want to and so that gives me a priority queue that it's very easy for me to extract the lowest cost element. And so that's really handy when I'm doing one of these like lowest cost paths, right? So you can see what I did was, you know, tuples sort lexicographically, right? So if I have, you know, if I have cost and then row and then column, then when I do heap pop, I'm going to get off the cheapest path I've found so far. And so what's going to happen is that, you know, by exploring that way, I'm basically guaranteed to find the cheapest path to the end because if you think about it, when I get to the end, I must have been adjacent to it. And the place adjacent to it was the cheapest place I knew how to get to, right? So that means that there are other places adjacent to the end. They were not the cheapest places I knew how to get to, if I even knew how to get to them at all. And so like every other square I could have gotten to was more expensive, so that's necessarily the cheapest way to get there. I don't know if I needed to do this visited set, but I think it probably made things run faster, would be my guess. You know, it was nice of Copilot to basically write breadth first search for me. You saw that it had a funny failure mode where it wanted to call the variable NR, even though I already had an NR shadowing that variable, and so that would have led to like a tricky bug to figure out. And so, but otherwise this is like relatively straightforward. And then you can see that for the growing the grid, I just screwed it up a couple times. No big worry. That's why we write unit tests. That's why we write this unit test in particular to make sure that I'm growing the grid correctly. Hopefully you're a believer in unit tests at this point because they save my butt every day. And yeah, that's that. So that wasn't too bad. Let's go see what the comments are. You can press escape to hide the suggestion. Some more coding madness sessions. Is coding madness like when I live coded the deep learning library? Because that probably not. That was like 5 years ago. That's just like a stunt I did once. It's all I can do to code these problems and solve these problems. But you never know. If I come up with some ideas, maybe I'll come up with some ideas. But at this point, the only plan I have is to try and finish out the 25 days of the only plan I have is to try and finish out the 25 days advent of code, and then do it next year. Maybe I won't take an 11-month break this time. I don't know. Any chance to stream live on the weekend nights? No. So no, there is not a chance of that, and the reason being, I simply can't stay up that late. Like it's not a matter of I have work the next day, and so I can't stay up that late. It's literally at like 9 p.m. or 9:30 p.m. I fall asleep, and so like if I made myself stay up an extra hour and a half to get to 11 p.m. when the problem drops, I would just be like I'd be half asleep, and I wouldn't do good work. So no, sorry, and it means I'll never make it on a leaderboard, and I'm in like last place in all my private leaderboards because all those people are on the West Coast. But anyway, that was that, and now I'm going to go shower.